Good day, grade 12 learners. Welcome to today's mathematics lesson. My name is Annelen Sindane. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Our lesson for today is a continuation of financial maths from last week, and today we are going to look at deferred payments, outstanding balances, and final payments. This part contributes about 8 plus minus 3 marks in our final examinations, and we know that financial maths contributes 15 plus minus 3 marks, and these are easy marks that we should get in our final examinations. At the end of the lesson, we should be able to understand the present value annuity. It was introduced last week and we are continuing from there. We should be able to solve problems that involve the present value annuity and the future value annuity. We should use present value formula to perform calculations. We should also use the present value formula to calculate outstanding balance, and we should make use of logarithms to calculate the value of n, which will represent the number of payments that have to be made. We should also be able to calculate the final payment that has to be made on a loan using appropriate formulae. Now we can refer to our CAPS document on the pages. It covers the work from grade 10 up to grade 12. So, as well as the examination guidelines for 2021, we go to page 6. Now, for our pre-knowledge, we have looked at the future value annuity, we have looked at present value annuity, we have looked at compound interest, we have looked at the derivation of the formula for future value as well as present value that was done the previous lesson, using the geometry, the knowledge of our geometric sequences and series. We should be able to solve word equations because in financial maths we are having lots of statements that we should interpret correctly, and we apply our mathematics. We should be able to do conversions from percentage to decimal and so on and so on. We should be able to use logarithms and exponents. We shall see this when we are calculating the value of n. Now, the present value formula. We know that for present value on a timeline, we should always expect a gap. You go to a loan, you are given the loan. There should be a gap between the time the loan is accessed and the time the payments commence. So we would say at T0, someone will get the loan. There is a gap at T1, T2, T3, T4, T5 until our Tn. Now, we should be able to distinguish between present value and future value. Future value, as it was discussed last week, you start making payments and you get a bigger value at the end of the investment period. But for present value, you get the money now, and at the end of the agreed period, the balance should normally be 0. You are paying back what you received now over a period of time. That's present value. And please note, if our interest is compounded quarterly, it means between the time the loan is awarded and the first payment, there should be a gap of a quarter. Now, we should also look at the monthly payments. If the loan is granted on the 1st of August, it means the first payment could be made on the 1st of September going forward. There should always be a month gap, and the timeline and the sum of all the payments takes care of that. But we should always check that when we are reading our statement, once we see there is a gap of a particular period, know that you are dealing with a present value annuity. Now, the formula to calculate the present value annuity is given by that one. And you are able to see that this one, our n in this case is a negative because we are trying to reverse the sum to p. That is why our n is negative there. And you know that the derivation was done last week, so I will not dwell much on the derivation, but I will dwell much on the use of the formula. So we know that our p represents the present value or the amount at hand. X represents our regular payments. Because this is an annuity, we have those regular payments. And our I represents the interest rate per interval. Remember, our interest has to be a decimal, and it depends on the compounding period that we are using as well. Our N is the number of payments, and we discussed this, that to get our N, it's not the number of years, but it is the number of payments depending on the compounding period. If it is compounded monthly, we know that we are going to multiply the number of years by 12. If it's compounded quarterly, we are going to multiply the number of years by 4 to get N, which is our number of payments, and so on and so on. Now, this formula is used when we have our large amount paid or received, because we can also use the present value annuity when we are dealing with big monies like inheritance money that is invested, but a person is getting a payment every month for sustainability and so on. So we should be able to interpret the scenarios correctly there as we are answering these questions, because it is not always a loan taken from a bank. Someone can take a lump sum of money, invest it, and as they get payments from that lump sum investment, it's considered as a present value annuity because they are getting payments on a regular basis based on what was invested as a lump sum. Now, let's talk about these big terms. Deferred. It's a new term for us. Now, by a deferred payment, I hope we have seen some of these adverts somewhere where you are told that you get an asset now, you start paying in 2023. That is considered as a deferred annuity. The annuity that you are going to pay will include the period from when the loan was granted up to until you start making your payments. So we always remember that there's always a month gap. So you will see how we work out deferred payments. So we are told that a deferred payment is when the payment of a loan is made more than one period after the loan was received. I've given you an example that someone wants to buy an asset now, and the conditions are you will start paying in 2023, January 2023. It means you are not going to start paying on the 1st of September, that gap that we had. So you will see how we work out that one. The present value annuity is still located one period before the first payment. You will see this as we do problems. And we will apply compound interest formula for the period when payments are not made, and we leave a month gap we calculate the new present value, a gap before the first payment is made. Now, a timeline is going to help us a lot in answering these questions correctly. Now, let's look at the approach to these questions. Number one, please read and understand the question or scenario. Read more than once. I have given a hint of saying, if the question says, so and so takes a loan, already what clicks into your mind? Present value annuity. So and so starts investing 1,000 Rand over a period of. It means they will get the money after a certain period that becomes a future value annuity. Read and understand the scenario. We move on. Please underline the key terms like, is it an investment? Is it a loan? Inheritance, I've given you the example that sometimes you get an inheritance of 10 million. You want it to take care of you for the rest of your life. It pays you certain amount so that you are able to live out of it. It becomes, you treat it as a present value annuity. Starting, because that's where we should be able to know how many payments you are making. Is it a deferred annuity? Is it a normal annuity where you just leave a gap? So those terms help us. Financial difficulty. When someone experiences a financial difficulty, it means they cannot meet all their financial obligations, meaning we can start having missed payments, where a person will have to make new arrangements to make sure that they settle their loan in the given time. Outstanding balance, because that's the money that needs to be paid. We'll talk about it later on. And step number 3, we interpret questions extracting key information like the loan, future value. I've highlighted this. You determine the correct formula to use. You determine the correct N, the correct M, and so on and so on. Step 4, you select the formula, you substitute, and you change the subject of the formula according to what you need to calculate. Here is an example. It was done last week, but we couldn't finish it. So I want us to start there so that we are able to see how deferred annuities work. Simpiwe takes out a loan, a 20-year loan. It means this loan has to be paid over a period of 20 years. She pays the loans by means of an equal monthly payment starting 3 months after granting of the loan. The interest rate is 18% per annum compounded monthly. Calculate the monthly payment. 3 months is bolded there. We have got loan. We are able to choose which annuity we are dealing with. Means of equal monthly payments. We know that this is an annuity starting 3 months after the loan, after the granting of the loan. Interest, we have it. Our time period, we have it, 20 year. So let's quickly extract the information. We are able to see that our present value is going to be 100,000. We are able to see that. Our interest is going to be 18% per annum compounded monthly. So we know that this is 0.18 over 12. And then to get the number of payments, our number of payments will be given by the number of years, which is 20, multiplied by the compounding period monthly, and that will give us 240. payments. Now, let's go back and we come up with a timeline to represent the scenario. I will draw my timeline like that. So at T0, I have 100,000 rands there. T1, T2, T3. At T3, we start paying. That's where I will put my X. T4 until I have my last payment at T240. I will have my X, and I know that the balance there will be 0, 0. Now, once again, we have the information, but we have to deal with the 3 months. The payments will start in 3 months. Payments will start at T3. So, what should we do to our loan amount? For the 2 months where we are not having payments, our loan amount is going to be accruing interest. So we use compound interest to calculate the new loan amount at T2. Remember, from T2 to T3, there should always be that gap that we talked about, because this is a present value annuity. There has to be a gap between the loan being granted and the payment being made. So you will compound grow 100,000 over 2 months. That will give us the new loan amount. And if we use the compound interest formula, our principal amount becomes 100,000. Our interest is 0.18 over 12. And then we calculate our new loan amount at T2, which is at the 2nd month, because we leave a gap before we start paying at T3. Could we quickly use the compound interest formula? Our N in this case is going to be 2. We substitute into the compound interest formula, and we should get our new loan amount as 103,022.50. This becomes our new loan amount. So when we substitute into the present value formula, we are going to take our loan amount as 103,022, not 100,000 as our loan amount there. Now, we are going to use the present value annuity formula because we now have our new loan amount. So our present value will be now 103,022.50. It's money, it's always to 2 decimal places. So we are going to use P is equal to X 1 minus 1 plus I to the power negative N over I. But now, before we substitute, we know what we are looking for. We can rearrange this formula and it becomes X is equal to, we want X, fractional line, P times I over 1 minus 1 plus I to the power negative N. Before we substitute, we need the value of N that we are going to substitute there. And we will realize that our N has to be recalculated because the loan has to be paid over 240 payments. But now we are going to say the loan balance, we calculated it at T2. So meaning the payments will start at T3. So to get the N that we are going to substitute in our formula, we are going to subtract our where we start calculating our balance, which is now the period that we are considering as our loan being granted. So it will be 240 minus 2, and that will give us 238 as our N. Also, if we do not want to use where we had our last month where the loan was granted, we can now use 240 minus where we have our first payment, and then we add a 1 so that we have the correct number of payments. Remember, from sequences and series, we're saying when we are dealing with sigma, it's always the upper value minus the lower value plus 1. So we are still doing that. So where is our first payment? It's at T3. So we say 240 minus 3, and that will give us 237. Then we say plus 1. So it means the number of payments will be 238. If you could quickly substitute into your calculators and calculate the value of x, I've already rearranged the formula. You substitute on the rearranged formula or on that one, and then you do the rearrangement on your calculator, and then you will get the monthly payment that has to be made. So the N that we are using here, we said it is the difference between that, and we said our N will be equal to 238. Let's quickly calculate. Now I'm going to do the substitution. We said it's 103. We will have and 22,50. I will substitute 0,18 over 12, all this over 1 minus 1 plus 0,18 over 12 to the power negative 238. You press your calculator and you should get an answer of 1591.35. We are done. So that is the answer that you should have gotten there. We move on to the next one. Let's move on to the next one. Yes. I will quickly give you 2 minutes to try and come up with a timeline to interpret this scenario. I'll give you 2 minutes to quickly come up with a timeline, and also try to do the calculations for the answer that we are going to have there as the number of payments that will be needed to settle the loan. 2 minutes. Right, welcome back. Now, again, it's a loan, 1 February, first payment 1st of August. Now, you can see the statement, regular fixed payments. It's a present value annuity. It's a loan, so we are able to see that this is a present value annuity. Our P is equal to X1 minus 1 plus I to the power negative N, all this over I, fractional line there. Now, let us check the information that we have. Let's come up with a timeline and see if we can be able to answer this one. So our T0, the loan is taken for 10,000. You are able to see that this is 1st Feb, we get the loan. Then we are told that the payment will be made on the 1st of August. T1, T2, T3, T4, T5, T6, T7. So this is the 1st of February. 1st of March, it's T2, nothing is paid. F2, T1, T2. So 1st of February, 1st of March, T1, no payment is made. 1st of March, T2, no payment is made. 1st of April, that's T3, no payment is made. 1st of May, that's T4, no payment is made. 1st of June, no payment is made. So the payment is made on the 1st of August. So let's check. This is February. We have March, April, May, June, July. So T5 is the 1st of July. No payment is made. And at T6, which is the 1st of August, that is when the first payment is made. So we'll put 450 there. T7, 450 is paid until we get to TN, the 450 as our monthly payment. Now, we are able to now say from the 1st of February up to the 1st of July, we are going to compound grow the 10,000 using compound interest formula so that we are able to get the new loan amount at T5. Then remember, we will have our gap before the first payment at T6 of 450 rands. So we are going to use the compound interest formula to calculate A is equal to P1 plus I to the power N. Remember here, we are not yet calculating the number of payments. We are just trying to calculate the deferred payment so that we get the new loan amount when this person starts paying off the loan. So we are going to substitute A, 10,000, 1 plus our interest. In this case, it's going to be 0.095 over the 12, because the interest is compounded monthly, to the power. How many periods are skipped? 5 months are skipped. So we are going to put this as power 5. The amount that we get here, becomes our new present value that we are going to use to help us get the number of payments that we are going to make. So in this case, we are going to get our final answer for the loan amount on the 1st of July as given by, we are calculating, it will be 10,402.15. That is the amount including interest for those 5 months. So that becomes our present value amount for the loan. Now we are going to substitute this into our present value annuity formula and we calculate our N. So in this case, we are saying our I, we have it. It's 0.095 over 12. Our N, we don't know. Our present value is going to be 10,402.15. And our X is going to be 450 Rand. Now, we have to calculate N. Remember, I even mentioned that as we practice doing financial maths, let's practice changing the subject of the formula, and this will come easier with more practice, and we will realize that it will be easier for us to substitute into the formula and get our answers right. So that is what I'm going to do now. We are saying from the previous one, when we made X the subject, we are able to say that if we multiply by the LCD, which is I, we will get P times I as equal to X, 1 minus 1 plus I to the power negative N. We are able to get that. Now from there, we want to make N the subject. So we'll divide both sides by X and we'll get P times I over X is equal to 1 minus 1 plus I to the power negative N. From there on, we want to make this term the subject. I'll take it to the left hand side and I'll have 1 plus I to the power negative N as equal to 1. I bring what I have on the right hand side to the left, P times I over X. Now, the N is on the exponent. So, but my calculator is going to help me get something there. So I will make N the subject, and I know that I introduce my logs, and I will know that my N, my negative N will be given by, we have log, we have the base, and we have the value that we have there. So what we are going to do, the base is 1 plus I. My value on the right is going to be given by 1 minus P times I, all this over X. So when I'm doing my simplification before I punch it, or I punch it on the calculator, I am able now to do the simplification and then I punch this on a calculator. It makes my life easier rather than substituting P there, X1 minus 1 plus I to the power negative N, all this over I. So I'll do my substitution there, but when I'm punching on the calculator, I'll punch on this one so that I get my answer faster. If I divide by negative, my N will be given by the logarithm, negative logarithm of base 1 plus I, and then on the other button, 1 minus P times I over X. Now, we will substitute. Our P is 10,402.15. Our x is going to be 450 brackets 1 minus 1 plus 0,095 over 12 to the power negative n, all this over 0,095 over 12. Now, let's quickly substitute our values there. This you must show formula and the substitution into the correct formula. The one I have on my left hand side here, it's the one that you are having on your screen on your calculator. Go shift, negative, press the log. Are you able to see that? That will come on your screen, the button below the on button there. Just press it, press a negative, press that log, it will give you that space. On your calculator, if you substitute 1 plus 0,095 over 12, it will give you a fraction which is a whole number. It's easier. You can punch that fraction on your calculator. You will get this as negative log. You should get an answer of, what are we getting? It should be 2419 over 2400. That's what you punch in there. When you simplify, what I have there is 1 minus, you put in place of p, you put 10,402,15 multiplied by 0,095 over 12 divided by 450. You should get 0,816999. You press the answer there, you should get your n as, depending on whether you moved your negative to the left or it's still on the right hand side, you will get, if you have moved your negative sign, this becomes a positive answer of 25,63 payments. Now, remember, this means the last payment of 450 Rand will be payment number 25. Meaning, to settle the loan, we can only settle the loan on the 1st of the next month. So meaning, when we calculate the number of payments, we are going to say they are going to be 26 payments. And we should be careful that the last payment that was made, the 26th payment, will be less than 450 Rand to settle off that particular loan. I hope it makes sense. We will move on now to the next part. It is the same question, but at least I've managed to finish it in the previous slide. We can move on now to the next part. Right. We are now going to look at missed payments. We know that in life it can happen that one gets into a financial difficulty and is unable to make the payments for a loan or whatever assets that they have bought using the loan facility. And we know that that person has to make sure that they communicate with whoever they are owing and they do not hide, so that they make arrangements using projections on when they can be able to resume their financial obligations of paying back what they owe. So we know that the new payment is normally higher than what they were paying before, and the payments now will be fewer. And remember, when you are owing, whatever you were supposed to pay is accruing interest the time that you are not paying, as you have seen with deferred payments. You take a loan of 10,000, you start paying later, it will gain interest for those months that you are not paying. And that is added to the original loan amount and you end up having a bigger loan principal amount than what you had originally borrowed or asked for. So to calculate that, we need to find the outstanding balance a period before when you make your last payment. Sorry, we calculate the outstanding balance on the period you make your last payment. Whatever is outstanding, the months that the person is not paying, that outstanding balance is accruing interest using the compound interest formula. So if you skip 2 months, it means it will be the outstanding balance, including the interest of those 2 months. That becomes your new loan amount. And when you calculate the new installment, it will be higher or bigger. Now, the outstanding balance on a loan at any given time is the amount that has to be paid to settle off the loan. And when we apply the compound interest on the balance till one period before, I've explained this, the result of the present value annuity becomes bigger, and we are able to now calculate outstanding balance. So outstanding balance, normally we use two different formulas. I will talk about them now. You can use where you compound grow the original loan amount and you subtract the future value of the payments that would have been made up to so far. The difference between the two will give us an outstanding balance. And the formula that you can use is given there. This is what we use for a normal loan. So if you have made 20 payments, it means in place of that M, we are substituting 20. You compound grow for 20 months or 20 quarters, depending on how the loan is structured. Where we have our X, those are the monthly payments that you have agreed with whoever you are owing to pay. And then the difference between the two will give us outstanding balance. And there's an alternative where we use the present value annuity formula. But now on this one, our N represents the number of payments that are yet to be made. It's not the payments that are already done, but the payments that are yet to be made. So this one becomes easier if you know the number of payments that you are supposed to make. Then you do your subtraction to get your N, the number of outstanding payments. Now, this is how we use the present value formula as explained there. We should know the value of our X for us to use this formula. N is the number of payments that are yet to be made. And the example that I will give, it's a loan that has to be repaid over a period of 5 years. You are told that you want to calculate the outstanding balance of the loan after 3 years. So here I'll have my T0. If the interest is compounded monthly, it means for the whole period we should make 60 payments. And we know that after 3 years, this means T36. So the outstanding balance is the amount that has to be paid from T36 up to T60, and you will get our N in this case is equal to 24. Then we substitute into our formula because we have 24 payments that are still to be made. We are not using 36. 36, remember, is the M, the number that have been paid up to date. Now, we will use this information to answer questions, and we are going to start by answering that question. I'll give you a chance 2 minutes, you attempt that question because we have talked about missed payments. So we want to find out the quarterly payments. Let's calculate the quarterly payment. So I'll give you 3 minutes. You answer A, then we will move together. I will only do the one that we have not yet covered. This one, we have done it. I'll give you 3 minutes to attempt it. Welcome back. I hope you managed to answer the question. Now, we are able to see that it's a loan, so we know that we are using the present value annuity. Our P is going to be 500,000. Equal quarterly payments starting 9 months after. Now, so remember, in this case, our T1 should be 3 months, our T2 represents 2 months, T3 represents 3 months. Because a quarter represents 3 months. So here we are looking at the number of quarters. So how many quarters do we have in 5 years? That will give us 5 times 4. So our N in this case, the number of payments will be given by 5 times 4, giving us 20. So it means the last payment will be made at T20. Now, let's try and look at this. Starting 9 months. So the first 3 months represents T1. The next 3 months means we are at 6 months, that represents T2, and the 9 months will represent T3. That is when our payments are going to start, after 9 months. But what do we realize? We are having 2 quarters where no payment was made. So the new present value, the loan amount, we must calculate it at T2, then we have our gap to start our payments at T3. Remember, there should always be a gap. So in this case, our gap should be equal to a quarter of a year, which is 3 months. So after 6 months, for the first 6 months, our loan is accruing interest. Then we calculate the final amount after 2 quarters, which is 6 months, and then we make our first payment after a quarter of year, which is month number 9 in this case. So we are going to compound grow. How many quarters did we not make payments? It's 2 quarters, so our N will be 2. So we'll have A is equal to 500,000. 1 plus our interest, it's 0.08 compounded quarterly over 4, and this is to the power 2, and this will give our A as 520,200. So you are able to see that if you do not pay, you choose to start paying after a certain period, you are no longer owing 500,000 before you start paying. You are already owing 520,200. That is your new loan amount. So when we calculate the new installment, we are going to be using 520,200 as our loan amount and no longer 500,000. So at T2, that's where we have our, and that is what we are going to consider as our loan amount, 520,200. We are now going to substitute. We are using the present value annuity. Our P is given by X, 1 minus 1 plus I to the power negative N, all this over I. We want X. So we are going to substitute 520,200 is equal to X, 1 minus 1 plus 0.08 over 4 to the power, we haven't calculated the N that we are going to substitute there, over 0.08, all this over 4. Now we go back to our timeline. How many payments are we going to have? Our first payment is made at T3, so that becomes, to get our N, we are going to say 20 minus 3 plus 1, meaning our N is going to be 18. So meaning here we substitute negative 18. We make X the subject of the formula, and we should get our monthly payment as 34,698.43 using our calculators. I hope that's the answer you got. We move on to the next part. Now, we want to calculate the outstanding balance directly after the 6th payment has been made. We want to calculate outstanding balance. So we looked at 2 methods of calculating outstanding balance. So remember now, to calculate outstanding balance, we can use outstanding balance as we calculated. We said it is P, 1 plus I to the power M minus the future value of the payments, which is given by X, 1 plus I to the power M minus 1, all this over I. So remember, in this case, our 500,000 is accruing interest when no payments are made. But now we have to be careful. We are calculating the balance after 6 payments have been made. If we go back to the timeline, sorry, let me quickly go back. If we go back to the timeline, remember, by the time we make the 6th payment, we are starting at T3. It means the 500,000 would have been in the account for 8 months, because remember, there are those two that were where we had a deferred payment. So when we calculate our M for this particular question, we have to be careful. We can't use 6 and 6 on the future value as well as on the compound interest one, because they are not the same. So I will move forward to the next slide and we continue answering that question. I was just highlighting from the timeline what we did. So to get our outstanding balance, we are going to substitute our N, their sixth payment, so meaning our M will be 6. But for here, we are going to have, I'll use 500,000 as my principal amount, 1 plus, I'm compound growing this. Our I, we calculated it is 0.08 over 4. Here, I'll use power 8 because it's plus the 2 months where we had a deferred payment. So 6th payment, we are going to say minus, open a bracket on your calculator, have your fractional button. Your X is the answer we got on A, which was 34,698.43. And then to get, we are going to grow this future value 1 plus 0.08 over 4 to the power 6 minus 1. Don't forget to close that bracket, over 0.08 over 4. You close the bigger bracket. You punch this on your calculator. The answer will quickly come out. Were you able to get the answer? Right. We should get our answer for outstanding balance as 366,947.80. That's our outstanding balance. So this person, after the 6th payment, is still owing 366,947.80 as the outstanding balance. I will now use the alternative method. I will use the alternative method to calculate the outstanding balance on that one. Remember, we said we can use outstanding balance is equal to X 1 minus 1 plus I to the power negative N, all this over our I. Remember now, we said N is the number of payments that are yet to be made. Now, to get our outstanding balance, we have made 6 payments, and to get our outstanding balance, we are going to say our outstanding balance will be given by our X. We got 34,698, what did we get as the 43? Then we have 1 minus 1 plus 0.08 over 4. All this to the power negative n. I will not put n now. I want us to check what we'll put as our n over 0,08 over 4. Now, let's calculate our n after the 6th payment. What will we have as our n? Quickly, remember, how many payments have been made? 6. 6 payments have been made, and remember, it's starting in 9 months time and ending in 5 years time. So 5 years after the loan is granted. So what will we use as our n? In this case, we have to put our n as, because remember, at T0 the loan was granted, T0. After 6 payments, remember, payments started at T3, meaning after 6th payment, this will be T8. And the final payment is at T20, meaning the difference between T20 and T8 will give us the total, the value of n that we are going to use there. So in this case, our n will be equal to 12. We punch this on our calculator and we should get our outstanding balance as 366,947,74. That is the answer that we should get there. We move on now to the next question. I will jump this one. I will jump that one as well, because we are going to get right. Now I'll talk about the final payment. We are saying for the final payment, the amount is fixed beforehand, and it is not usually possible to settle the loan by an integer number of equal payments. In such cases, there will be the last payment, which is smaller than the others, to settle the loan, and the payment is made after the last full payment. We calculated the value of n on the previous one. We got 25,63 payments, and we said payments will be 26. So, meaning the 0,63 something something represents the installment that will be the outstanding balance, which is less than the monthly payment, which is regular. So what we normally do, we calculate outstanding balance of what has to be paid after the last installment. For example, if we are getting our n as 25,63, it means we will calculate our outstanding balance at T25. So we will get the outstanding balance there as whatever we get as the outstanding balance, because it will only be paid either on the 1st of the next month or at the end of the month if payments are being made at the end of the month. And you will realize that we'll compound grow whatever is the outstanding balance after the last full payment, and we compound grow it for only 1 month, and we should be able to get our final payment, which is normally and usually less than the full installment that has been paid all along. Now, let's quickly answer this one. It will take us a few minutes because I want us to cover the missed payment as well as the final payment on this one. Let's quickly answer this one. I'll give you 2 minutes to answer the first one. 2 minutes, let's answer the first one. We have done how to calculate N. 2 minutes, let's calculate. Right, welcome back. I hope you were able to answer this one. As you can see, it's a loan. We are using present value. Our loan amount is 375,000. Our interest is 14% per annum compounded monthly. Now, we do not know the number of payments. So we need to get N. So remember, we are going to use, let's have our P is 375,000. Our I, it's going to be 0.14 over 12. Our N, we don't know. And our X is equal to 7,500. Now, so we write down the present value annuity formula X 1 minus 1 plus I to the power negative N, all this over I. We do the substitution. 175,000 is equal to 7,500. 1 minus 1 plus 0.14 over 12 to the power negative N, close bracket, all this over 0.14 over 12. Remember, we said after rearranging, we got N is equal to negative log. You simplify 1 plus 0.14 over 12, and that should give us 607 over 600. When we simplify after rearranging 1 minus P times I over X, that should give us an answer. So that will give us 1 minus, let's check, 37500 times 0.14 over 12. We are punching this on the calculator over 7,500. Punch your equal sign and you should get your N as 74, 477. Yeah, you will finish it up later, but the question is, how many payments will George have to make? So our N in this case will be given by how many payments? Sorry, it's 75, not 74. 75,47 something. So it means we round up because the payment is either going to be made in the following month. So we'll get 76 payments. Now, let's move on to the next question. Now, we are supposed to calculate the outstanding balance immediately after the 75th payment. Now, in this case, I will use my outstanding balance. My payment every month is that one. And I know that when we calculated our N, we got our N as 75,477 06563. That is the last payment. Now, it means we want to calculate the outstanding balance after T75 and the difference between T75, 477706563. Now, I want us to use the other method now to calculate the outstanding balance. Our outstanding balance remains as a fraction there. So we'll just say 75 minus that becomes our N. Our N in this case, the N that we are going to substitute in our formula for outstanding balance is equal to X 1 minus 1 plus I to the power negative N over I. We want to calculate outstanding balance. So I will use my X is 7,500. 1 minus 1 plus 0,14 over 12 to the power negative 0,47706563 over 0,14 over 12. We punch this on a calculator. We should get an outstanding balance of how much? Let's quickly calculate the outstanding balance. Now we should get 3,547,46. That's the outstanding balance immediately after making the 75th payment. Now we want to calculate the final payment, which is the last payment that will be made. So remember we said the final payment, I'll use A is equal to outstanding balance, and I'll treat the outstanding balance as that 1 plus I. And this will give us, let me use OB so that you remember what you are taking as your principal amount and you compound grow it for 1 month. So the final amount that you are going to pay, it's going to be A, or I use X, is equal to, we got our outstanding balance as 3,547, 1 plus 0,14 over 12. You punch, sorry, I forgot the comma 46 here, so that we have 1 plus. It's 3,547,46 bracket 1 plus our I is 0,14 over 12, and this will give us our final payment as 3,000. We got 3,588 comma 84. That would be the final installment that is paid for that loan. Now, I would want us to quickly answer this question. I'll give you 12 minutes to answer it, and we will discuss the solutions after 12 minutes. Let's quickly try to answer it very fast. I hope you have managed to work out 7.1, 7.2 up to 7.34. This is an interesting question, and let's quickly look at it. Now, Tabiso took out a loan of 250,000. It's a loan. The interest is 15% per annum compounded monthly to buy a car. The loan has to be repaid commencing on the 1st of July 2016 and ending 4 years later on 1 July 2020. However, Tabiso is unable to make the payment of the first 2 installments and only commences with full installments on the 1st of September. So this one, it's a straightforward one. We are able to see that the loan is granted and the first installment has to commence on the 1st of July, but it's not made. So T0, T1, T2. And we are told that the first installment is commencing on the 1st of July and ending 4. However, he's not able to make the first 2 installments. So we know that from T0 up to T2, we are compound growing. So we'll compound grow that 250,000 over 2 months, over 2 months, and that will give us the answer there. So you'll get a mark for substitution and a mark for the answer. So the loan was 250,000. For skipping 2 months, he's now owing 256,289.06. We move on now to the next question. Tabiso will still have to pay his last monthly installment on 1 June 2020. Calculate his monthly installment. Remember, we are saying on our timeline T0, the first payment, T2, there was nothing, gap. Our first installment started at T3. So there's a month gap between this, and we are saying our present value now, we are looking at 256,000. You remember it from the previous question. That becomes, we have our gap and we start paying. Remember, 4 years times 12, that means it's T48. It means the loan has to be paid over 48 months. But now, what do we have as our N that will substitute into our present value annuity formula? So we'll say 48 payments minus the 2 that were skipped, or we'll say 48 minus 3 plus 1, and that will give our N as 46. So the N that we are going to substitute in order to help us calculate the X in this case will be given by, our N will be 46. We substitute into our present value annuity formula and we should get our monthly installment as 7,359.79. That is the new monthly installment that Tabiso has to pay. We move on to the next one. So for this one, we are substituting correctly. We get a mark for our N there, and substitution, and we get a mark for simplification, and we get our final answer. Remember, there's a mark also for the correct formula there. So correct formula, our I, substitution, and our N there being 46, we get a mark, and the mark for the final answer there, we get 4 marks. We move on to the next one. Tabiso opted to increase his monthly installments starting on September 2016. How many months sooner will he repay the loan? How many months sooner? So we are calculating our N, and you will realize that we are still using our present value annuity formula, and we are calculating our N. So in this case, remember, we calculated the loan amount. Remember, payments did not start on time. It's a deferred annuity. So as our principal amount, we should remember to use 256,289.06, and the interest, we are having it there, and we are calculating our N. So there is a mark for the correct substitution into the correct formula. Our P is that one, and we get a mark also for the use of our logs, and we get a mark for the answer N, and then we get our 36 payments as the number of payments that were made, and then we get our answer for calculating the 10 months sooner, because we want to find out the number of payments that will be made for this one will be given by 36. A mark for using the logs, we have it there, and then the conclusion, 10 months sooner, it's what we should get our 5th mark for. We move on to the last question. If Tabiso paid 9,000 as an installment starting on September, calculate the final installment to repay the loan. Now, remember on this one, we have calculated the number of payments. We got them as 35, something. So we will calculate the outstanding balance after the 35th, after the 35th installment that was paid, because that's a full payment of 9,000. Whatever remains, we are going to compound grow it for 1 month, and then we get our final payment. So this is how we are going to quickly do it. So we calculate the balance using any of the given formulas. You will find out that using the formula where we compound grow the principal amount and we find the difference, and then we grow the outstanding balance after the 35th payment will give us 3,735.45. We compound grow it for 1 month, and the final payment will be 3,782.14. Using the other formula where we calculate our outstanding balance using the present value annuity, our N is the decimal that we got on the answer for question 7.3, and remember our X is our monthly payment, 1 minus, we substitute the interest, and then our N, it's what still has to be, is the decimal part of our difference between the full installment and the last one, and that will give us the same answer there. Now, we have discussed this. Now you can quickly take that one. You will do it later on at home. Take a picture of it, and also you take the following question. You can take a picture of this one. It's from the exemplar question paper 2014. You will do it later on at home, and you are able to get the solutions from the DBE website. If you get the memo of that question, it will help you a lot practice what we covered today. Our deferred payments, our outstanding balance on a loan, as well as the skipped payments. It will cover it all, and also calculating the of n, where we want to calculate how sooner can the loan be paid off on our question. Now, in summary, we looked at deferred annuities where the payment of a loan does not begin after the gap, but it actually begins after a certain period that was agreed on. Remember, there should always be a gap between the loan and the start of our payments. Now, for deferred annuities, we compound grow the period where the loan was not paid, and we always have to give a 1 gap period before the first payment commences. And we use the present value annuity formula. Outstanding balance, we have 2 methods of calculating the outstanding balance, and you can use whichever you are comfortable with to calculate your outstanding balance. If there is a missed payment, remember the outstanding balance is grown using the compound interest formula for the months that there are no payments, and we always have to leave a period gap before the payments resume, and normally the new payment is higher than the original payment that was agreed on. And then the final payment, it's normally less than the other monthly installments, and a timeline is drawn to help us interpret the scenario. It makes our life easy to see the questions. Wishing you all the best, and let's continue to practice and be safe. Have a good afternoon.